across the U.S. So I am the CEO. My Chief Operating Officer, co-founder John Ogle's on the call. Also our Chief Marketing and Business Director, Capture Director Elizabeth's on the phone online here, and then we have Warren Gedge, our CTO, who will be given the brief today. So without further ado, I'll turn it over to Warren so he can share his slides and provide the lunch and learn. And at any time throughout the talk, please feel free to raise your hand or ask any questions, and we'll be happy to answer those. Thanks. So over to you, Warren.
Thank you. Yep. I'll do that first because.
Really quick before you jump into the content, is this okay for this to be recorded for this meeting?
Yep.
Okay, awesome. Thank you very much.
Okay. See if I can get rid of this little sucker there. Oh, there we go. I figure out how to get it back later. We're Symbiosis. We're here to talk about advanced manufacturing infrastructure, the applications of security and within knowledge and data management across vendors and across areas that involve both using quantum and AI, and the benefits to that for manufacturing and defense, and then also within machining. It's a pleasure to be here, and thank you for having us. Today's webinar specifically is going to focus around Zero Trust, NIST 800 series, as well as the use of integrations, AI, data management and operations, going across vendors and applying those things to frameworks such as the security frameworks and actions and to your operational parts, and how those can both be beneficial from both a security and operations perspective, but also from a profit perspective, and how all of it coincides together and how those things can be implemented together in today's world. Factories, machines, properties, they're all shifting to secure or trying to be secure facilities. But with that gets increasingly difficult with the amount of digital equipment and assets that are floating. It also becomes more difficult with staff moving between those operation centers, with a lot of those things being requiring different communication channels that have different issues, and also being able to hunt down those things within the asset parts and how those different things go and track them, not just internally, but externally, and how that falls through the entire supply chain. Inside of a factory or inside of a manufacturing plant or inside those logistics parts of the localized areas themselves, having staff moving around all the time, having assets coming in, having the business, operations, security, and property, and that all on a different page makes it difficult for IT or security to help secure things and find those different assets or to track those parts. Same token on supply chain, for what many of you do, having an extra part at the end or being short a part at the end where you're not supposed to is a problem. And tracking those parts and making sure that people are getting the right things and making sure that all those different assets together is a good aspect for those different areas too. Some of the trends, smart factories and defense manufacturing. We all know that they're modernizing. We all know that sensors are being applied to different parts, but none of those manufactured people work together, not natively. So now you end up with different systems. Then you compound that with the way that things are purchased, with spend cycles, write-off periods, contracts and parts, and you end up with smart factories that are disparaged. You end up with properties that have different vendors that don't connect together, and you end up with both legacy and new issues all trying to tie together, all being human-driven. But the trend to moving those to AI is in place, and people are trying to take advantage of that. Where quantum comes in a very good way for that is for coming up with calculations or applying engineering principles to those parts in order to come up with better ways, in order to come up with better directions. It's also very good at taking lots of little data currently being used within engineering and manufacturing as well, and coming up with models, specifications, and nuances in order to make a better decision or be able to do predictive analytics in a much finer grained attitude. Advancing defense manufacturing with AI and virtual technologies. Again, it's not just about the assets, but we're also creating digital worlds. And we're doing that in order to try and do streamlining with our operations and engineering parts of our companies. We're doing that to try and secure as well as be proactive with things, but we're creating more digital assets. And those digital assets require communications. And within that, you expose more entry points, and then you also expose more areas. Good for business, but it also creates other things. We build smarter and safer and help. We've got a novel technology that essentially is, in the old days, you'd call it middleware. Nowadays, it's not quite so middleware because it's not dumb, it's smart. We've been training deployable models and algorithms within products that go down to electrical level and use engineering principles and security principles in order to go cross-vendor and cross-communication, all the way from the IoT and device market and PLCs, all the way up into documents, files, databases, and structures like that. But going across and using engineering and security principles also gives you a unique perspective, because that allows you to get rid of the integration issue and the timeline as to what do I have and what is it doing. Now you take all that and you apply that to something like a framework, like a NIST 800 or Zero Trust, and you can start to get a real accurate picture of what's going on, and how it applies to you, and you can now get awareness, situational awareness, sorry, into those different parts. We help in many different ways, and we apply quantum and AI in different aspects. Yes, we do enter fee on the keys, like a lot of other people do, or that's kind of a mainstream part, or bleeding edge to away. We're also moving it down into the key management area so that depending on your segments, your buildings, your areas, your assets, you can actually have different enter fee quantum keys within those. We're also using it in order to help find anomalous trends within small data sets and create models, as well as scientific technologies apart for AI, in order to help do the predictive parts, in order to help figure out where and what's going on. And then also, it's very good at allowing you to come up with algorithms and science to go and follow it back to do collection. It's not good enough just to figure out what's going on. Often in what we do, you need the paper trail. You need all the little data points that go with it, so that you can make a better decision, or it can help you make a better decision. The need for advanced cybersecurity. I think we all know that we need to stay secure, and that manufacturing has been a target for a long time. With the more digital assets out there, with the more manufacturing people out there, with all the different tools and the globalization out there, do you really know if your security is being run out of India? Who knows? I mean, people do their due diligence to go back, but you'd be surprised in a lot of cases. Do you know if your IT or your security are all tied in together between physical loss prevention as well as the operations and security stack? They're often actually not. Um, Having zero trust is great, but you need to tie that into how your products and your software products and how your data structures are working in conjunction with the people that are using them. And for that, every location is Snowflake. It really is. And the reason for that is people make them that way. Applying those parts across the vendors and across the different stacks to standardized compliance frameworks and operational procedures and safety and loss prevention, as well as the other parts, allows you to get a contextualized output of what should happen. And then we also allow you to do actions. So depending on different threat levels, depending on different assessments on there, we can gather all the information, but depending on that, we can be human intervention or in the loop, or you can move away. Where quantum plays really well with this, in today's world, taking a lot of little data points and applying it to the quantum world in order to come up with calculations, models, and formulations, it's used quite widespread within, I'll say, engineering, metallurgy. Actually, a lot of this audience, some of the big players do use it in order to do their calculations for coming up with metal densities in different areas. It's also used within agriculture and genetics for genes and for different parts like that. And by that, I mean more seeds and different parts that we're doing out different networks within that. The same principles also apply to your network. It's taking a lot of disparaged data, or what appears to us to be disparaged, but it's not. It actually comes and has its overlaps. And rather than putting it into a way of letting people try and figure out what it means, it's lining up those data points in order to allow people to understand what it means. It moves the conversation forward, and that allows actions. It's not just science fiction. It's not something that's, coming in 20 years of that. It's actually moving pretty fast. Um, in the quantum world, for example, I mean, yes, there's a lot of money going into the weird things like the super cooled and different parts, but there's a lot of advancement at room temperature. IBM Quantum, for example, has a room temperature photonics that you can use in your car or attach it to another computer that. But there's other shops that are coming out with other room temperature parts for doing calculations and different things. So there's quite a few different advancements going on that are allowing this to happen, not just in the cloud, not just connected to your system, but also to get off grid. Great for security. Quantum also is very good at complex things. It's very good at taking a lot of little things, a whole ton of things, and coming and lining it up for you. Using that with AI is a great placement because AI is very good at taking instructions and looping and doing different parts to that and transforming. And honestly, a lot of AI in today's world is really just advanced machine learning and different areas of that science. All very works well with great loops. Figuring out those parts and putting quantum systems in those loops is very good, is in today's realm and things that we do as well. It provides a competitive edge and it allows you to go across those manufacturers and to make a better decision at a computer level as to where to go next and to also help somebody make sense of what's there. Then again, applying those to a framework, anomalies always bubble up to the top. And those are, in the security realm, that's a red. That's a thing that you should log, look at, and go and see. In the operations world, that's money being lost. Those anomalies, I mean, those are things that somebody should go look at. In the IT world, those are things that are running at a higher expense than they should be. There's those anomalies within those cross network across your properties and your assets on multiple properties, and those assets actually have a story to tell on those anomalies. One of the things that it also makes it great, going backwards in time. And by that, I don't mean going backwards in time in the weird physics way, but within using legacy systems and going back on the communication stacks with that. Yes, Scott, I saw a hand up.
Hey, Warren. Yeah, thanks. Great job so far. I just wanted to kind of do a pause for a second and poll the audience to see if you have any questions so far. All right. No questions yet. All right, Warren, keep going. Thanks.
Yeah. How does all this help? Using security, operations, all those different parts, really, they have a need within your organizations. And they're not separated. They actually all can be enablers for your organization. They can help you save money, help you make money, help you reduce risk, help you control and understand risk, help you optimize to your customers and to the different parts around that. People are already using AI in a lot of different aspects for that, or trying to move in those directions, right? But where quantum and AI come together is all those big calculations and all those different parts can be very easily put down into tiny models, small formulations or different aspects within that, and allow for that to actually happen. So it's more of an enabler, and it's a way of helping to bring all those different pieces together, which get you those operational efficiencies. By tying together those different systems and allowing actions to go backwards and forwards, you actually gain insights into what's going on, and you also gain actions that keep you from having to do some of those parts. One good thing, for example, is smart cities. On the smart cities part, a lot of the smart technology is really one way. If you want to get those engineering or those changes that your staff are making on the smart city itself, that's a big process. It's PM driven. It's not just test it out and let's see what happens and get the feedback loops and get those different parts. Quantum can enable those things, right? If you're trying to follow your supply chain across suppliers and across those different properties, right? On the onset, that seems like a complex thing, but underneath the covers, those patterns and those ways that those industries have put those things together and they've been productized and sold to you or you've sold to them actually have standards behind them and have ways that those are done. Quantum bubbles all those up. It helps give you all the different anomalous aspects around those pieces in those formulations. Tying together the data enables those different areas and then also enables those other products that you have within your stack and your sunk costs to be worth even more and to bring more value to you. Insights into all your different areas and how they're actually working at an engineering and security level to the users themselves. There isn't a product on the market at the moment that will tell you what a product is doing with its data set. You can learn what a database is doing or a data set, for example, in a robotic arm or in your laptop or in the servers running your company. You can figure out what the app is doing. Nobody ties them together. Nobody actually tells you how they're working together. The way you find out that there's a problem with them working together is they stop responding, so IT and operations get involved. Metrics go off because there's an issue with performance on them, or security has an issue with them. But nobody actually ties those things together. AI in our approach allows you to tie those things together irrespective of the data structure or the application. That also allows cross-application data structure intelligence. So if you're on an assembly line, tying together those robotic arms to those other PLC systems, that information applied to security standards, to your operational procedures and standards, that's real insights. That's what quantum AI and those formulation algorithms allow you to do and what we're doing and the aspects around those parts. And the field is advancing quite quickly. But getting all those different parts together actually enables a really unique view on how they're working. Compliance and scalability. We recently went in for a auto manufacturer and essentially they do tours of their plant, so they're smelt centered because they're really proud of it. Security has those tours onto certain areas. Somebody threw a Raspberry Pi underneath one of the parts with a multi-scanning Wi-Fi on it and was stealing that car manufacturer's schematics and engineering documents and all of their IP. Yes, it's encrypted, but it wasn't. But the entropy on it was normal entropy, and that is the entropy is the combinations or how different the keys can be. Somebody had been taking the data already. Wherever that is, it's being decrypted right now, or they're trying to decrypt it, and realistically, they'll probably crack it at one point. Finding these things, stopping them from getting out is one part. There's another part of making it so that what ifs, they can't be cracked. And there's another part of actually being able to go in and get it back or to stop it from being used. All of these parts allow you to tie together to compliance reporting, vendor integrations, and scalable parts across your properties and assets. Bring and tie things together and help enable you to make better decisions and protect your business. Optimizations. Yes, Joey.
Yeah, I had a quick question. So
Yeah.
a lot of our PMs and a lot of our partners are working with OT systems all the time, different manufacturing processes as well as machinery. So what specific problems in the manufacturing process can be addressed with quantum computing and AI? And what does that mean for the future?
Well, we work with Siemens, Honeywell, ABB, Schneider Electric. There's a slew along that. And realistically, we solve quite a few problems in that. On the security front, knowing the behavior of your manufacturing plant and having that report to your security people in those different realms in real time will actually follow that down. If a device or something funny is going on, following that back and collecting the evidence that you need or the reasons for that logic to allow those people to make a better decision, we also solve that. Many times, manufacturing plants have two other problems that become more or three. Loss prevention, tying operations and security into the systems. If they've got humans in the plant, then you also have different robotic systems generally within the plants. Those robotic systems tend to not always be the same manufacturer. Tying those together into your digital twin and driving it back is another problem we solve. And then another one within that would be optimizations across those different aspects of that plant tied into security enforcement and your operations procedures. So we can help you influence those plants and help drive those efficiencies, understand what each of those things are doing so you can get into maintenance, proactive maintenance. We can help you understand the security posturing, and then we can also help you gather all the evidence around that, and we can follow those parts back to it. At the same token, we can also enable two-way communication between those data structures and those parts. So not only do you know how they're working to the parts, but you can also know what they're actually doing. That enables shift changes. That enables plants to change between their different things. For example, if it's the food industry, although I know we're talking defense, or if you're changing it up to do different parts for defense things, all those different parts need to line up downtime because one of those parts didn't line up when the plant switched its protocol or switched its piece leads to days of downtime. Loss prevention on the safety side, reduced insurance rates, because we can tie into the parts for human loss prevention within that, not just for theft, but for health and safety for those parts tied into security, which ties into the parts. So there's a wide range of benefits when you talk about tying together the data structures within that. That answered the
Awesome.
question?
Thank you very much.
Oh, cool. And feel free to say hi, anybody, whenever. It's really hard to see the little hand pop up in the middle, but
Yeah,
our
this is
product.
Gino's.
Hello.
I got a question since you asked about
Yep.
this. Understanding that there's many parameters that go into what a system looks like and what it's going to be done at the end of it. What's a ballpark range from, maybe the low end of a smaller scale implementation versus the higher end? I guess what kind of scale have you been working at, and where do you see maybe the bulk of the level of effort that you all put in from a cost perspective?
So at the low level, I would say we have financial audit firms that are doing U.S. government records and aspects around that and calculations for auditing within the U.S. government. On the higher side, we've got Hawaii, Singapore, 80% of the U.S. cities. We're in every, for example, in New York, we're in every operations room, every pumping station, every control station. We do the government of France. We've got a U.S. government entity where a lot of their data flows through. We're middleware, so that doesn't mean, and I mean that it can sound dirty, but by having intelligence there, it's not traditional the way it was back in the 80s. So I would say most of our cost value, it goes the whole range, from small implementations all the way up to bigger parts. I would say it's disparaged data. It's mixed up file servers and databases. I would say it's having a lot of assets. And I would say it's having a lot of legacy systems. And those kinds of things are universal problems across, and then it scales up. We currently have deployments in Azure, AWS, AWS Gov, Siemens, and such. So there's a lot of flexibility in the different parts, and then there's also off-prem as well.
Great.
So it really depends on the customer, but there's a lot of
Yeah.
flexibility to get around the security or the segmentation parts that just businesses have.
Yeah, that's great. Thanks for sharing that. I guess at some point, maybe this is later in your presentation, is there a little bit more about the company itself, where your broad
Yep.
geographical locations, number of staff, things like that?
Yep. I can talk to those parts on another slide, or I can let Scott talk to those parts. Scott, do you want to talk to those parts? I just say it now.
Yeah, sure. Thanks. Just really quick. So we are small, but we can scale through the hyperscalers, which makes that nice. We're lean and nimble. We're less than 10 total right now, but with our partners, we're probably over 50. We're spread out throughout the U.S. We have offices in DC, Atlanta, and Salt Lake, Utah, and then some in Toronto and Canada. So that's kind of the geo makeup of the company. We're in seed, moving into A series funding for VCs. Does that help answer the question?
Yes, thank you.
Sure, no problem.
Yep. We're a small shop, but we punch hard. We also have deployments going into Iron Bank and a few other things as well. And we scale on technology that helps people.
Thank you.
No problem. What can quantum AI offer manufacturing? Well, it can offer protection at a cryptography level. It can help tie together legacy systems and new systems. It can help bring together those disparate assets. It can get around the distance issue of bad communications. I mean, a lot of manufacturing plants are not in the downtown core of a city where they're all jacked up to multiple different city grids with all kinds of extra things. A lot of them are out in the suburbs or out in the country, or somewhere that, you know what, people do hit those hydro poles, or things do happen and those systems, I mean, quantum can help with those as well. Keeping it so your assets are safe so they can't get out. Quantum's good at that. Helping to help you make sense of where things are so that they can be applied to frameworks and standards or your operational procedures or your policies. That's where it can help as well. It's really good at going across all the different principles that we take for granted at a lower level, tied in with AI and tied in with some other architectural pieces so that you can actually move it around. It becomes quite valuable. I know a lot of the audience that's doing manufacturing that is using quantum in their parts on the engineering side. I've mentioned that already. A lot of our parts are the same applications, but to different areas of science and to different areas of technology and operations. Can quantum enable applications for manufacturing? It can help bring together a lot of your issues. It can help enable your existing systems. But for a lot of people, I mean, we can store data for you if you want. A lot of people have storage units, and a lot of times it's taking it out of storage units and putting it back in so that those existing systems will function properly or be able to find the things. Being able to find all those different threats or odd movements. You know, if somebody starts to take something out of a file server really quickly, that's an anomaly. You put that into a NIST framework and you've got a red on a screen. If that red goes high enough because the data is doing certain things or going in certain places, you can automate those actions. You can tie the same thing into operational efficiencies down to the engineering, operations, electrical levels. So now you can also start to save money. You can make your plants more efficient at the same time too, and you can just apply the same principles back. Thank you for your Thank you for having us, and thank you for being a part of this. We like to say that we empower resilience, intelligence, and security and awareness. Not just situational, but also just awareness in general about your organization, the operations, and the way that the security and its awareness is. Well, thank you very much.
Thank you, Warren. Great presentation. I just wanted to add to that we are in a program with the Defense Innovation Unit, the National Security Innovation Network. We were recently down selected from 300 companies due to our novel IP that we have. And we do have high side capability, secret access. It's called IL Cloud, and that's with the U.S. Navy. Can be rolled out into other kind of DoD networks. So just wanted to throw that piece out there and open the floor to any questions. Thank you.
What is your web address?
Our web address, symbiosis.
I'll put it in chat for the group.
Okay, cool. Thank you.
Yeah, I had it down in a meeting invite as Symbiosis.io. And when I clicked on it, it popped up a GoDaddy thing that said this site is available to purchase.
It's
I don't think that was the correct address. I'll put the correct one in chat. Sorry about that.
That's all right. I just wondered.
Oh, there you go. Beat you to it. Oh, maybe not. Oh, look at that. We got a few.
Thanks.
Thank you. I hope this was informative for people. It's not about inventing the world. It's not about doing Star Trek things. It's actually just about applying current technologies and advancements in a way that helps remove your problems and your challenges and enables your business to make better decisions. And all the things we're talking about, they're not exclusive from each other within any real organization. They all bring value and tie things together, and they can all help, and they should all help enable the business. So, thank you.
Warren, thank you so much for your time and going through the slides. I just had one last question before we finished up. The last one I had on my list was just how with quantum AI, quantum computing and AI, how do these technologies align with long-term manufacturing strategies?
How do they align? Well, quantum is the ability to make use of take, quite honestly, a lot of information of really small data at the atomic level. Applying it at a real level to a lot of things is what the world is trying to do, and there's trillions of dollars going into it at a global level. But really what it's all being used for is to make better decisions and calculations. The technology is far enough ahead at the moment that applying that into AI models and algorithms, and then that into normal technology stacks, allows you to take a lot of different scenarios and get it right. It allows you to get rid of the problems across many of the vendors and how they, oh, we work together, but we're all slightly different. It gets around those parts. It helps you move the conversation from what is it and where is it to, oh, here's what it is and here's what it's doing. And then it helps you to bring relevance and context to it by applying that to the things that you've written or that you follow so that you know what it means. It's not just information. But quantum in a real sense and AI in a real sense are both advancing fields. And it's only inevitable that people like us will tie them together and start to do things with them. But they do different things. But they are merging. So.
Yeah, good answer, Warren. And the nice thing about it is too, even though they're emerging, we have operational technology that we can put into use now that can help companies out significantly, including government entities that are out there. So that's the kind of the beauty of the technology.
Well, thank you very much for those answers and going through the slides. Is there any other questions for the team? If not, thank you everyone for your time. We really appreciate it. And we thank Symbiosis for coming on and teaching us about their product.